For nearly 50 years, one engine produced a sound unlike anything else on the road, a screaming two-stroke diesel that powered World War II tanks, landing craft, city buses, trucks, and fishing boats. While most engines disappeared decades ago, thousands of these legendary Detroit diesels are still working today. In this countdown, you'll discover how the Series 71 became the legendary Screamin Jimmy, why it dominated American industry and the military, and what finally ended one of the greatest diesel engines ever built. And stay until the end, because you'll find out why mechanics still consider these nearly 70-year-old engines tougher than many modern diesels. Let's get started. Section 1. The problem nobody else saw. By the late 1930s, diesel engine technology was trapped in a paradox. Diesel power worked. It was proven, it was durable, it made incredible torque. Trucks and buses and ships ran on it. But there was a ceiling nobody could break through. Diesel engines in that era were massive. A typical diesel for industrial use sat somewhere around 3,000 to 5,000 pounds. Slow revving brutes. They made power, but they made it at low RPM with enormous displacement. You couldn't fit them into a truck without redesigning the truck's entire frame. You couldn't put them into a bus without sacrificing interior space. And the military especially, had no use for an engine that weighed as much as it produced in horsepower. Gasoline engines had solved that problem. They could rev high, pack light, and produce usable power from smaller packages. The trade-off was fuel economy and durability. Gasoline engines needed constant maintenance. They burned through fuel like machinery didn't matter. General Motors saw the gap, and instead of accepting it as an engineering limitation, they asked a different question. What if we didn't have to choose? What if we could build a diesel engine small enough and light enough to compete with gasoline engines for weight and packaging, without sacrificing diesel durability and efficiency? It was the right question at the right moment, and it led to the creation of the Detroit Diesel Engine Division. Section 2. The radical approach to manufacturing. Here's what made Detroit Diesel different from every other diesel manufacturer on the planet, and why that difference mattered. Every other company building diesel engines in the 1930s and 40s operated on a bespoke model. Sulzer built diesels. They built them well. They built them one at a time, custom engineered for specific applications. Same with Fairbanks Morse. Same with practically every other manufacturer. You came to them with a specification you needed a marine engine with 4 cylinders and 80 horsepower, saying they designed it for you. It took months. It was expensive. It was precise. And it was, by definition, not mass-produced. Detroit Diesel rejected that entire model. Instead, they adopted an approach that wouldn't fully mature in the automotive world for another decade: modularity and interchangeable components. They designed a family, a single basic architecture, a single set of cylinder dimensions, and then they built that family across a range of configurations: 2 cylinders for small equipment, 3, 4, 6, 8, 12, 16 cylinders, arranged in both inline and V-block formats where everything that could be interchangeable was. The Series 71, named for 71 cubic inches of displacement per cylinder, became the foundation. Every Series 71 engine, regardless of whether it was a 271, a 371, a 6V71, or a massive 16V71, shared the same bore dimension, 4¼ inches, the same stroke, 5 inches, the same basic combustion chamber design, the same fuel injection strategy, the same mechanical supercharger arrangement. This sounds obvious now. Every modern automotive manufacturer builds this way. But in 1940, it was revolutionary. It meant that a factory trained to build one engine family could produce dozens of variants without redesigning core components. It meant that a fleet operator could stock common parts and repair kits. It meant that maintenance training wasn't model-specific, it was family-specific. But the real innovation went deeper than manufacturing efficiency. Detroit Diesel built the Series 71 as a 2-stroke diesel. That architectural choice was where everything else flowed from.
Section 3. The 2-stroke advantage and the cost.
Here's the fundamental difference between 2-stroke and 4-stroke diesels, and why it matters for understanding what Detroit Diesel achieved. A 4-stroke engine fires once every 2 crankshaft revolutions: intake stroke, compression stroke, power stroke, exhaust stroke. 4 strokes to make power once. Most diesel engines on the market today are 4-stroke. They're efficient, they're clean burning, they fit modern emissions regulations. A 2-stroke engine fires on every crankshaft revolution, power on one revolution, exhaust and intake preparation on the next. Twice as many firing events per minute at the same RPM. The power density advantage is obvious. At 1500 RPM, a 2-stroke diesel is making power twice as often as a 4-stroke running at the same speed. That's why a compact 2-stroke, when the piston reaches the bottom of the power stroke in a 2-stroke diesel, exhaust ports open in the cylinder wall. The spent combustion gases have to leave. Fresh air has to come in, and these events happen almost simultaneously. If you're not careful, if you don't get the exhaust out quickly and completely, and fresh air and cleanly, you end up with 2 problems. Incomplete combustion, fuel that exits the exhaust ports unburned, and a mixture of exhaust gases and fresh air swirling in the combustion chamber. The solution is forced-scavenging, a supercharger, not as a performance option, but as a fundamental requirement of engine operation. Every Detroit diesel came equipped with a Roots-type supercharger. It wasn't optional. It wasn't for high RPM boost. It was mechanically bolted to the engine and driven by the crankshaft itself. Its job was to cram fresh air into the cylinders at the moment they needed it, to scavenge out the exhaust gases, to ensure complete combustion. The blower spun at roughly 7 times crankshaft RPM. At 1500 engine RPM, the supercharger was turning at 10,000 RPM. At 2100 RPM, it was screaming at 14,000. At higher RPM, it hit 20,000, 25,000. That's where the distinctive whine came from. That's the sound that became known, decades later, as the Screamin Jimmy. That sound was the engineering. It was the evidence of forced scavenging happening in real time. Section 4. The War Machine. In 1940, as American military production accelerated, Detroit Diesel's gamble on manufacturing scale and modular design alignment paid off in a way nobody at the company could have predicted. The Series 71 became the backbone of the Allied war effort, not the entire effort. Gasoline engines still powered most vehicles, but for applications where reliability, power density, and durability mattered, where an engine failure in North Africa or the Pacific could cost lives, the Series 71 was the first choice. By 1943, the Detroit diesel factory was producing 57,000 engines per year. One engine every 10 minutes. Not in total, per shift. That production volume made the Series 71 the most proliferated military diesel engine of the Second World War. Those engines went into applications across the entire military spectrum. Tank engines. Medium tanks and heavier combat vehicles used Series 71s because of the torque density and the compact packaging. A 6V71 could produce 300 horsepower from a package small enough to fit into armor, with the reliability characteristic necessary for combat vehicles where an engine failure meant abandonment or loss of life. Amphibious landing craft. The LCV landing craft vehicle personnel, the 36-foot plywood boats that carried troops from transport ships to invasion beaches, hundreds of them at Normandy on June 6, 1944. Most of those boats were powered by Series 71s. The power-to-weight ratio meant speed. The reliability meant they could be serviced on the fly, even under combat conditions. Navy patrol vessels. Subchasers and minesweepers and coastal patrol boats. Marine applications loved the Series 71 because the forced scavenging architecture meant high power output in a compact package, and the mechanical fuel system meant no exotic maintenance infrastructure was necessary in forward operating areas. Trucks and transport. The 6x6 trucks that hauled supplies across every theater of operations. Deuce and a halves and larger freight vehicles. The Series 71 was the power source. Section 5. From military production to civilian dominance. The transition from military production to civilian application forced Detroit Diesel to make a decision. What market should they target first? The answer wasn't trucks. It was municipal transit. City buses. That was the first massive civilian market to embrace the Series 71. And the reasons are worth understanding because they reveal something about how the engine was actually engineered. A city bus runs in stop and go traffic. Constant acceleration from stops, constant braking, maximum engine load at low RPM, frequently throughout the day. It's mechanically demanding. A gasoline engine in a bus in 1946 or 1947 would be completely worn out after 5 years of city service, burning oil, needing constant maintenance. The Series 71, specifically the 6V71 and 6-cylinder V configuration, capable of about 250 horsepower, transformed municipal transit. These engines could handle the duty cycle. They provided torque at low RPM. They could rev high when needed. Most importantly, they lasted. A Series 71 in a city bus could run for 50,000, 60,000, 70,000 miles without major overhaul. That was revolutionary. That meant transit authorities could actually calculate return on investment. The fuel economy wasn't spectacular. This was a diesel in 1948. Fuel economy was a secondary concern, but the reliability meant the total cost per mile actually decreased over the life of the vehicle. Detroit Diesel recognized this success and doubled down. They started building specific Series 71 configurations for different civilian applications. The 6V71 for city transit became nearly universal in American cities. San Francisco, New York, Chicago, Los Angeles. If you rode a city bus in the 1960s, 1970s, or 1980s, you probably rode in a Series 71. But that was just the start. Fire departments embraced the 8V71, 8 cylinders, 800-plus horsepower, maximum torque at low RPM. Fire trucks need to respond instantly and pull hard under extreme load. The Series 71 was ideal. Marine applications became a major market. Everything from fishing boats using 671 inline configurations to massive tugboats using 16V71s. The marine industry loved Detroit Diesel because the engines could provide continuous power under maximum load day after day without failure. A fishing boat runs its engines hard for weeks at a time. The Series 71's ability to maintain output and reliability under continuous operation was exactly what marine operators needed. Construction equipment. Bulldozers, cranes, excavators, drag lines. The ability to produce maximum torque at low RPM made the Series 71 perfect for heavy machinery. These aren't highway engines that need to rev high for power. These are engines that need to lug down to barely above idle and still pull with authority. The Series 71 did exactly that. What made these engines truly special and what genuinely separated them from competitors was their tolerance for abuse. Operators discovered that the Series 71 could handle overloads. It could handle poor maintenance. It could operate under conditions extreme heat, extreme cold, high altitude, contaminated fuel that would destroy other engines. The robust construction and conservative tuning meant that even when pushed beyond rated limits, they rarely suffered catastrophic failure. A Series 71 wouldn't explode. It wouldn't seize. It wouldn't throw a rod. It would run hot and loud and angry, but it would run. That reputation became gospel in industries where reliability meant money. By the 1950s, Detroit Diesel owned the market for heavy-duty diesels in ways that competitors simply couldn't match.
Section 6. Market expansion and technical evolution.
In 1957, Detroit Diesel introduced a new platform that revealed something important about the company's understanding of market segmentation. The Series 53. Displacement. 53 cubic inches per cylinder. This was smaller than the Series 71. It was lighter, it was more compact, and it was designed for one specific application: over-the-road trucking. The American highway trucking industry was growing rapidly in the 1950s. Long-haul trucks were starting to dominate freight movement. In 1965, Detroit introduced the Series 149. This was Detroit Diesel taken to the extreme. A massive engine designed for mining operations, large marine vessels, and stationary power generation. Heavy-duty behemoth. Available in configurations up to 20 cylinders. Over 3,000 horsepower. Built for maximum power and durability, where weight and fuel economy were secondary concerns. In 1974, Detroit introduced the Series 92. This was a refinement of the two-stroke architecture based on decades of operational data. Improved combustion chamber design. More efficient scavenging. Reduced fuel consumption. The engines were marketed as fuel squeezers because they delivered better fuel economy than earlier two-stroke designs without sacrificing reliability.
Section 7. The four-stroke pivot and the beginning of the end.
In 1987, Detroit Diesel introduced the Series 60. This was not an evolution of the two-stroke platform. This was a completely new engine, a four-stroke diesel, a clean sheet design that represented an abandonment of the philosophy that had defined the company for nearly 50 years. Why would Detroit Diesel, the company that had built its entire reputation on two-stroke technology, suddenly pivot to four-stroke? The answer is regulatory and competitive pressure that made it impossible to continue with two-stroke architecture. But something unexpected happened when Detroit Diesel stopped building two-stroke engines. Those engines refused to die.
Section 9. The Resurrection and Modern Cult Status.
Today, more than 30 years after Detroit Diesel stopped manufacturing Series 71 engines, they're still operating, 50, 60, 70 years old, running, making power, being maintained and rebuilt. City buses in developing countries still run Series 71s because the engines are indestructible and replacement engines are prohibitively expensive. In Latin America, in Africa, in parts of Southeast Asia, buses that were exported in the 1960s and 70s are still operational, still carrying passengers, still maintaining the schedule, still burning fuel, and producing that distinctive two-stroke whine. Commercial fishing vessels still run Series 71 and Series 92 engines because marine operators understand that these engines will start reliably and run continuously under conditions that would challenge modern electronic engines. Make these engines ideal for remote marine operations. Sawmills, power generation facilities continue to operate equipment powered by two-stroke Detroit diesels because the engines simply refuse to wear out. When properly maintained, a Series 71 can accumulate tens of thousands of hours of operation while maintaining its original power output and reliability. But the most surprising market for vintage Detroit diesel engines has emerged in the restoration and collector community. Diesel enthusiasts have embraced Detroit diesel two-strokes. Section 10. The philosophy of mechanical simplicity. The cult status of Detroit Diesel's vintage engines extends beyond nostalgia or collecting. These engines represent a philosophy of engineering that prioritized durability and serviceability above efficiency and emissions compliance. In the current era of increasingly complex diesel engines that require specialized diagnostic equipment and dealer-only repairs, the mechanical simplicity of a Detroit diesel two-stroke seems revolutionary. Modern diesel technicians who work on vintage Detroit diesels often express genuine amazement at the engine's design. Everything is accessible. Everything is serviceable. Everything is built to last. No dealer programming, no software updates, no complex assembly procedures. The contrast with modern engines is stark. A current production heavy-duty diesel engine, whether it's a Detroit DD15 or a Cummins or a Volvo, is an extraordinarily complex machine. Modern diesel engines are, in many respects, more sophisticated and more impressive than engines that came before. But they're also not something you can understand by understanding mechanics. They're something you understand by understanding software and electronics and how those systems interact with mechanical systems. They require training that's specific to the system. They require diagnostic equipment. They require dealer networks with expertise and parts inventory. A Detroit diesel two-stroke is the opposite.
Section 11. Technical Legacy and Influence.
The technical innovations that Detroit Diesel pioneered with the Series 71 influenced diesel engine development for decades, even after the company moved away from two-stroke technology. But it became the foundation for how all heavy-duty engine manufacturers design engines today. A Cummins B, C, or L series maintains architectural commonality across configurations. So do modern Caterpillar engines. So do Volvo engines. Detroit Diesel's story is a story about engineering choices, about what happens when a company prioritizes durability and repairability over efficiency and compliance, and builds their entire reputation on that choice, about what happens when that choice becomes incompatible with the world the market demanded, and about what happens to those creations, those legendary machines, when their creators moved on. The Series 71 didn't fade into history because history was kinder to it than to other engines from its era. It survived because it was so well built, so over-engineered, so obsessively designed for durability and field repair that it outlasted the entire market it was designed for. Somewhere right now, a city bus in Latin America is running a Series 71 that was manufactured in 1970. If you're interested in rare automotive content, mechanical systems, and the history of industrial engineering, subscribe. We cover the vehicles, engines, and engineering stories that major automotive channels miss. Drop a comment below if you've ever heard a Detroit diesel two-stroke at full throttle, or if you're curious about one of the other legendary engine families that built American industry.